Hello and welcome to my channel. In this math video tutorial, we want to solve this problem of integration. But when you're looking at the problem, you observe that you can't use the direct integration formula to resolve this problem. And for you to be able to walk through this, you need to apply the integration by parts. So that's the method we're going to use for this problem. So say using integration by parts. So what we need to do is to quote the formula. The integral of u dv equals uv minus integral of v du. So this is the formula for integration by parts. If you've not come across that, at least you've seen it right now. So what we need to do is to teach you how to use it to evaluate this problem. But meanwhile, if you're just new to this channel, please hit the subscribe button, like this video and turn on the notification bell so that when I upload new video you get notified. And again, make sure you share the video. So let's watch along. So what do we need to do? Comparing this original equation that has upper and lower limits to this integration by parts, you observe that we can put this u for x squared. That's to say, this u is taking the position of x squared and dv is taking the position of exponential 3x dx. So what do we need to do at this point that we substitute u for x squared? We need to take the differential function of this u with respect to this x. So the derivative of u with respect to x squared is 2x using the differentiation formula. So now we have du over dx to be equal to 2x. We can cross multiply this x. This is more like y over 1. So if you cross multiply 1 to u, you then have du equal to, if you cross multiply the x by 2x, you have 2x dx. So that is for that. Again, we have dv to be for exponential 3x dx. So what we need to do for us to eliminate this derivative symbol is to take the integral of dv, and then we also need to take the integral of exponential 3x dx. Because we added integral to this left hand side, we need to do the same thing to the right hand side. So that's the reason why we are introducing integral, so that we can be able to use this integral sign, because when integration meets with differentiation, they cancel out. The same way when logarithm or ln meets with exponential, they cancel out. So we have v remaining equal to, if you integrate this expression using chain rule, make here to be u, then you have 1 over 3 exponential 3x plus constant c. So if you don't know how I go through this process to have this, then let me use this space to fix that for you. How I got this, the integral of exponential 3x dx using chain rule. From chain rule, we have that this is what we want to differentiate, exponential 3x. So this is what you're going to do. Just make u to be equal to this 3x. That means you represent this 3x with u, so that you now have this to be exponential u. That's the integral of exponential u with respect to u. Alright, on this part, this u that you represent with 3x, you need to differentiate the u with respect to x, and the differentiation of 3x is just 3. So if you flip this up, taking the x up and then bring the u down, that means the x over du will be equal to, y is over 1, so it becomes 1 over 3. Alright, so this expression becomes integral of exponential u dx over du dot du. So this point, what is this dx over du? Is 1 over 3. So I need to take the 1 over 3 back. So I have 1 over 3 exponential integral of exponential u du, and integral of exponential u is still exponential u. So we have 1 over 3 exponential u plus constant c. But remember that your u was 3x, so you have 1 over 3 exponential 3x plus c. That's how we got this. I hope this was helpful. Please make sure you like this video right now and hit the subscribe button if you've not done that already. So let's progress on the next phase of it. So now we need to apply everything into the formula. All what we've gotten, we need to substitute into the formula. The original equation says the integral from negative infinity to 0 of x squared exponential 3x, x squared exponential 3x dx is equal to, so this is taking this position, equal to, what is your u? The u we had was x squared. So x squared multiplies by v. The v we had was this one. So we have 1 over 3 exponential 3x. We don't need to add this plus constant c at the moment because we are still using it in the expression, minus. So what do we have here? We have integral of, your v is 1 over 3 exponential 3x, right? And then we also have our du. Look at du to be 2x dx dot 2x dx. So this is what we have. We've plotted in everything into the formula for integration by parts. So the next thing we need to do here is to say that the integral from negative infinity to 0 of x squared exponential 3x dx will be equals, if this x distributes into this, then you have 1 over 3 x to the power of 2 exponential 3x minus, we also need to multiply this through. So if 2x multiplies by this, we have 1 over 3, 2 multiplies by 1, that will eventually give us 2. So let's put it there directly. So x will be left, and then exponential 3x dx. Alright, so let's keep this normal. The integral from negative infinity to 0 of x squared exponential 3x dx will be equal to 1 over 3 exponential x squared exponential 3x minus, we want to take the integral of this, and this will also take the shape of integration by parts. So but then let's remove this constant, let's keep it out here, and then take the integral of x exponential 3x dx. So at this point, looking at this, we can't use direct integration on this. We still need to apply integration by parts on this particular one, then later bring the results in the system. So what should we do? So we have to write this. Apply integration by parts on exponential x, integral of x exponential 3x dx. So of course, to remind you of the formula, this is the formula for integration by parts. We need to write it again so that you will see clearly how I'm making the direct substitution. Alright, so this is the formula. Let's do the direct substitution. We have your x taking the position of u and exponential 3x dx taking the position of v. So here we have u to be equal to, we substitute the value of u because u is taking the position of x, and then we also have that if you differentiate this u with respect to x, the result you have is 1. So if I cross multiply this x to this one, then I'll have du to be equal to dx. Alright, And then for dv is equal to, what do we have? Exponential 3x. That's what we have. So now I'm going to take the integral of dv with respect to the integral of 3x. And then if I integrate this, of course, you know that this the derivative will cancel the integral sign, then you have v to be equal to, if I take the derivative of this using that same chain rule which I've done earlier, we have 1 over 3 exponential 3x plus c. So that's the result. So if we are to plug all of this into the integration by part formula, we have that integral of x exponential 3x will be equal to, from the integration by parts, from this formula, your u, we have u to be x, and then v is this. So we'll be having that x multiplies by the next one is 1 over 3 exponential 3x, right, minus the integral of the right hand side. We have our v to be the whole of this, and the u is just the x. So we just have the right hand side to be 1 over 3 exponential 3x times the x. So having arrived at this point, we need to also say that the integral of x exponential 3x will be equal to, if this multiplies through, we have 1 over 3 x exponential 3x minus, so here we need to bring this out, and if we do that, we'll be having 1 over 3 integral of exponential 3x dx. So what's the next line of action? This will imply that 1 over 3 x exponential 3x minus 1 over 3, if you take the integral of this using chain rule, you have this to be 1 over 3 exponential 3x plus c. Alright, so this means that at this point we'll be having 1 over 3 x exponential 3x minus, if you multiply this by this and 1 by 1, 1 by 1 is 1, 3 by 3 give 9 exponential 3x, alright, plus constant c. So what will be the next thing? We need to put this together, or take whatever it is we've got in here into the original equation. Keep in mind that this is the left part of the right part of the equation that we need to integrate. That's what we just have. So in order to do that, we will need to put the whole of this into that left hand side. So what is that left hand side exactly? Let's check it. So this was what we applied the integration on, this expression. So the result we have the whole of this. So you need to take all of this and replace it by the whole of this. Apart from this 2 over 3, the whole of this shall be represented with this. So let's do that right away. So here we have the integral from negative infinity to 0 of exponential x squared exponential 3x dx to be equal to, what we have initially, what we started with was 1 over 3 x squared exponential 3x minus 2 over 3. Then we have to put in the whole of this into it, which is 1 over 3 x exponential 3x minus 1 over 9 exponential 3x, and then we don't want this plus c at the moment, right? So this is what we have. But if you really want to put it, it's not a problem. It's not going to affect our work. But when we want to apply this upper and lower limit into the system, we may not be needing it. So let's use this 2 over 3 to distribute across this. So we have that the right hand side will be 1 over 3 x squared exponential 3x minus 2 times 1 will be 2 and 3 times 3 will be 9. So we have 2 over 9 x exponential 3x minus, we affect this minus to be positive. 2 times 1 will be 2 and then 3 times 9 will be 27 exponential 3x and plus c. So this is what we have. So now we need to apply this upper limit and lower limits to this expression. In order to apply it, we say that the integral from negative infinity to 0 of x squared exponential 3x dx will be equal to, we apply the upper limit first. So we have 1 over 3. Anywhere we see x, we have to replace it with 0 exponential 3 multiplied by 0 minus 2 over 9 into 0 exponential 3 multiplied by 0 plus 2 over 27 exponential 3 multiplies 0. Alright, that's what we have here. And then we close this section minus. So on the lower limit, we have 1 over 3 into negative infinity all squared exponential 3 multiplies by negative infinity. Alright, we have that to be minus 2 over 9 into negative infinity exponential 3 multiplied by negative infinity plus 2 over 27 exponential 3 multiplied by negative infinity. So that's all. So but then I want you to keep this in mind, that when you have exponential 0, the result will be 1, and you take this from the 0 law of indices. And then also if you have exponential infinity, the result will be 0. So if you keep this in mind, then you notice that on this left part, the whole of this will become 0. The whole of this also will be 0. The whole of this will be 0. How? 3 multiplied by negative infinity will be also infinity. And if exponential infinity, we have exponential infinity, that will be 0. 0 multiplies by this will be 0. That's the same method that works for this, and also work for this. So that means the right hand side has vanished. Then for the left hand side, we have that negative infinity to 0 x squared exponential 3x dx will be equal to, on this part, 3 times 0 is 0, x to the power of 0 is 1, but here is 0, 0 squared is 0, 0 multiplies by anything makes it 0. Similarly, for the 0 to be here, if it multiplies everything here, it will be 0. Here we have 2 over 27 exponential, 3 times 0 is 0, exponential 0 is 1, and 1 times 2 over 27 is 2 over 27. So here is the solution to this problem. Thank you for watching this video. I hope this is helpful. Please make sure you like this video, share this video, drop a nice comment if you found this video helpful, and hit the subscribe button, turn on the notification bell so that by the time I upload the video you get notified. I am Instructor Alison. Bye bye.